Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're talking about a math topic that is a little bit of a riddle. So the question is, when is a solution not a solution? And in order to answer that, we need to know what a solution is in the first place. So without further ado, let's take a look. Okay, big riddles today. When is a solution not a solution? So probably the first thing we want to define is what is a solution? So a solution is basically the answer to whatever problem you are doing. The interesting thing is, on the SAT specifically, you'll see other synonyms for what the solution or answer is. And so maybe take a second to think about one of those. All right, if you have one in your head, what do you got? We have solution, maybe an answer, maybe a root. You may know that. So a root is a solution to a quadratic. Anything else? You may be thinking, well, maybe that's a factor. A factor is also a solution a lot of the time. You may say, well, what is a root but a zero of a quadratic? Or what is a zero but also just the x-intercept of the quadratic as well? So it's always a fun exercise for me to ask this question and then just keep saying, well, what else? What else? Because there are a lot of things there's a lot of synonyms for what a solution is on these tests. So any of these words means exactly the same thing. It just means the answer to the problem. So when do we not have solutions? Well, first of all, we have this little factoring problem that I put together here. They say for all x greater than 5, simplify the following. And if we're sort of just not really paying attention, we just say, okay, it probably looks like factoring. X squared plus 2x minus 35 factors to x plus 7 and x minus 5. And then x squared minus 3x minus 10, that factors to x minus 5 and x plus 2. And so we can get rid of the x minus 5, and we have x plus 7 over x plus 2. And we go, great, sure, fine. And that's probably one of the answers. And if we're not really paying attention to the wording of that problem, we breeze right through it, and we get it right. But what I see oftentimes is students sort of get hung up on this, where x minus is greater than 5. So why is x greater than 5? Well, the reason that we have this is that there are some things that will happen when our input is less than 5 that we don't necessarily like to do in algebra. So just for example, what happens, and I'll clear this out, what happens if x happens to be -2? Well, what we've done there is we put in -2 for all these, and we get 5 times -7 over -7 times 0. And what does that mean that we're doing? Well, it means that we're dividing by 0. And when we divide by 0, what happens? Yep, nothing. We don't really know. It's a non-continuous result. We're not sure if it's negative infinity or positive infinity, and that is tough for us to resolve. And so what we go ahead and do is we don't. So the reason that they say here for all x greater than -5 is this discounts the instances when we are dividing by 0. So in this case, it would be for 5 and for -2. So we don't want to do that for this just straightforward factoring problem. So that's why they say that in these tests. If you're ever wondering, that's what it's there for. Just don't think about the asymptotes. Maybe in a future video, we'll do asymptotes. That's effectively what's happening here with these divide by 0 in the denominator questions. That does come up in the ACT, so probably worth talking about in the future. For now, though, we're going to talk about extraneous solutions. So first of all, what does extraneous mean? Well, extraneous just basically means extra. And in this case, extraneous means it looks like it would work, but it actually doesn't. So what I've done here in these two graphs is I've plotted y equals x squared on the left-hand one. And for those of you who covered inverse functions this year, maybe you know that if you wanted to get the inverse of y equals x squared, you'd flip these and solve. And so you'd say that this is x equals y squared. And if we were to just plot x equals y squared, it would look like we had rotated this graph 90 degrees this way. But the problem with this is it doesn't pass the straight line test, and so we can say this is not a function. So instead, what we go ahead and say is that this is y equals the square root of x, which looks like this second graph. And so when we have an instance where we have something that would fail the straight line test, we change the way that it outputs so that it does not. And so if we were to have something like the x value of 3 there's this output, but there's also theoretically another output down here that we're just discounting, because the square root of a number when there's one solution is always positive. And so we can also see that in the form of math here with this question, the square root of x plus 2 equals negative x. And so if we were to try to solve this with conventional math, maybe what we do is we just square both sides, and we get x squared equals x plus 2. And then we would solve that by subtracting x minus 2 from both sides. We say this is x squared minus x minus 2. And we could factor that to just be x minus 2 times x plus 1. And we would think that our solutions were 2 and negative 1. But the problem arises when we plug these in. So if we plug in 2 to root x plus 2 equals negative x, that would be root 2 plus 2 equals negative 2. And the square root of 4, which is 2 plus 2, is 2. And 2 is not the same number as negative 2. And so that's an example of an extraneous solution. And so when this happens, you might be thinking, well, what do I do? How do I know that something is extraneous or not without plugging it in after I've done all the algebra? And specifically for the kind of question like this that you'll see on the test, the answer to that is work less. So the way that this question will be phrased to you is you'll be given this, I'll clear this out. You'll be given this sort of algebra with a root in it. And so if you see algebra with a root in it in a question, what you're going to want to do is just start plugging in the numbers. And so what this will do is prevent you from having to do all the algebra, and you'll get an answer really quickly. And in the event that this is in the non-calculator section of SAT math, which is where this usually will be, they will never give you difficult numbers. So it's a pretty straightforward request to just like throw negative 1 in here and go, all right, well, the square root of negative 1 plus 2 is equal to negative 1, and negative 1 plus 2 is 1, and negative 1 is also 1, and that checks out, as opposed to what I just showed you with the extraneous solution where it was not the same value. Okay, pretty focused lesson today as far as equations and topics go. Have 2 practice problems as usual, so go ahead and try the first one here, and we'll see how we do. All right, let's take a look at the first one. So we're saying for all x greater than 7, so just something to basically to ignore, just to say we're not worrying about any sort of asymptotes. And then we have this x cubed plus 4x squared minus 21x over x squared minus 49, and looks like we're just going to factor that. So if we have an x cubed right here, they're never going to ask us to do any sort of interesting cubic factoring on this test. It's always going to be, hey, pull out an x, and then you'll be left with something that you can factor much more reasonably. And for our denominator, we have x squared minus 49, which hopefully you picked up on was difference of squares. So great callback to my video on difference of squares from way back. Always be looking for this. They just love to do that on these tests. And so now that we have the denominator factored, we can pretty easily factor the numerator here, which is going to be x plus 7 times x minus 3. And that all factors out, or should do. You cancel out our x plus 7s, and then we are left with x times x minus 3 over x minus 7, which is answer C here. All right, second practice problem here. Go ahead and try this and see how you do. All right, let's take a look. So we've got the square root of 3x plus 40 equals x, and what are the solutions to that? Having seen the root, hopefully you didn't try to solve this all out. So let's see how this goes. So we just go ahead and say, all right, well, how about 8? And then we say, okay, this is 3 times 8 plus 40, and let's see if that equals 8 or not. And so 3 times 8 is 24, and 24 plus 40 is 64, and indeed the square root of 64 is 8, and 8 does equal 8. So definitely that one. And so we can get rid of none of the above. And so how about 5? So that's the square root of 5 times 5 plus 40. Let's see if that equals 5. And so that's going to be 15, or 25 plus 40. Sorry, 3 should be in there, excuse me. 3 times 5 plus 40. And that's going to equal 15 plus 40, which is 55. And the square root of 55 is not 5. And so we can go ahead and say that it's not that one. And 0, the square root of 40 is not going to be 0, so there's no 0 solution there. And so we're left with just the first one. Okay, that's it for this video. So if what we covered today feels a little bit complicated and kind of difficult, well, that's because it is, or at least according to the SAT and ACT. This topic would definitely be considered one of the hard questions and appear later in the sections that you'll see. So if you're having any trouble with this, please be sure to reach out to us so we can provide you with some great tutoring. In any event, if you found this material useful today, please be sure to like the video and subscribe to Quiet Education. Thank you for watching, and I hope you have a great day.